Welcome to lesson 3.9, the perpendicular bisector. So in our last lesson, we looked at perpendiculars, and remember, perpendiculars meet at 90 degrees or a right angle. Bisectors are what we're going to dive a little bit deeper into in this lesson and the idea of perpendicular bisectors. So a bisector of a segment. A bisector of a segment is a line, ray, or segment that intersects a segment only at its midpoint, meaning it cuts it into two equal parts. So it's bi, two parts, secting, to cut something. So a bisector cuts into two equal parts. So intersecting a segment at its midpoint. A segment can have many different bisectors. So that's drawn in this diagram down here. Lines L, M, and N, these three purple lines, are all bisectors of segment AC at point B. So they all go through the midpoint of B for AC. A perpendicular bisector is a special type of bisector. So again, it's a line, ray, or segment that intersects a segment only at its midpoint and forms a right angle at the point of intersection. So perpendicular bisector, line, ray, or segment that intersects another segment at its midpoint and creates a 90-degree or right angle. There is only one perpendicular bisector to each individual segment. So in my example over here, line M is the perpendicular bisector of segment AC. That should say AC, not AB. My apologies there. So that should be AC, not AB. So it's the perpendicular bisector of AC, meaning it cuts it at point B, the midpoint, and meets it at 90 degrees. So then there's steps, 5 steps here, on how we construct a perpendicular bisector. And in order to do these constructions, you need 2 things other than a pencil and paper. You would need a straight edge, and you would need a compass. So then you'll see on page 2, so if I go down to page 2 here, I show you the final construction of a perpendicular bisector, what it looks like. Now, there's a couple extra notes on there, but what I'm going to do is I'll create a separate video taking you through step by step how to create this perpendicular bisector. And then on page 3, the other construction that you'll see in the notes is constructing a line perpendicular to a line through a given point. And that diagram down here shows you how to create that. And again, I'll create a second video walking you through step by step how to do these 2 different constructions. But before you watch that video, if you want to try one on your own and see how it turns out, there are step-by-step directions in the book, which are also similar to these 5. So the first step would be to draw segment AB. Then you'd construct a circle with the center point A and the length AB as the radius. So you would set the compass from point A to B and then leave it at point A and draw your circle. Then you would go to point B and leave the compass at the same measurement and draw another circle. And the 2 points where those circles intersect are the 2 points that you combine to create that bisector. So if we look at this drawing here, when I created this drawing, it was based on first having segment AB. You set the point of the compass at A and set it to the width of B. From there, from point A, you would start to draw your circle through point B. Then you set the compass at point B, set the distance to A, and start to draw that circle. You can see I didn't draw the full circles, I only drew partial circles or arcs. Where those circles or arcs intersect above and below your line are the 2 points that you connect to create your perpendicular bisector. So again, those 5 steps, I'll take you through another video explaining how to do that step by step. But once we've constructed a perpendicular bisector, we now know a few things about that drawing. We would know in my drawing point E is the midpoint of AB, because that's where it crosses through. We would know that the distance from A to E equals the distance from E to B, which means segment AE is congruent to segment EB. And then we also know the line that we drew, line CD, is the perpendicular bisector of segment AB. And then that idea of bisectors and perpendicular bisectors help in scenarios when we have Voronoi diagrams. So in this case, explaining these types of diagrams, it says in the real world, there are more than 2 airports and more than 2 cell phone towers. Granted, we definitely know that. The figure at the right started with 3 points, X, Y, and Z. So we had X, Y over here, Z here. Which points in that overall plane are closer to X than to Y or Z? So we're wondering which points are closest to X, and then also wondering which points are closest to Y and which are closest to Z. So as it says here, by drawing perpendicular bisectors of the segment XY. So if we had a segment XY there and we drew its perpendicular bisector, that would give us this line here. Then we do the perpendicular bisector of XZ, giving us this line here, and the perpendicular bisector of YZ, giving us this line here. What that does is it breaks the figure, or this plane, into different regions. That allows us to say points in those regions are closest to a given point. So that's how they would determine things like which airport airplanes should land at, if there's many in a similar geographic region, or which towers your cell phone will be relayed from. So if you were in this darker gray area in the upper left, those are all the points closest to X. Over here, we have all the points closest to Y, and down here, all the points closest to Z in this section. So the type of diagram that's created by using these perpendicular bisectors is called a Voronoi diagram. And it's named after a Russian mathematician, Georgy Voronoi. But the idea for this diagram is if you have multiple points, you can construct the perpendicular bisectors of the segments that connect those to create a diagram showing different regions for points closest to those given original points. So then the final piece that we're looking at is the idea of simply constructing a line perpendicular to another line through a point. So these steps, these 4 different steps, came right from the book, and they go with the diagram down here on page 3. So the first thing that they do is they give you, and I just drew my own, if you're given a line AB and some point C, what we want to do is construct a line perpendicular to AB through point C. So the steps in order to do that, the first step, if we go back up here, is given A, B, and C. So draw line AB and point C on your paper. Then you're constructing a circle with the center C and a radius CA. So what you would do is once you knew where C was, you would set your compass at C, open the measurement to A, and then you're going to draw that circle. So I end up with this top circle here. Then the next steps, so once we've constructed that, then the next steps will tell us to name the intersection of that circle and line AB, and we would label those intersections another letter. So coming down here, I use D because it's the next one alphabetically. So here we have our circle at center C. We know it intersects at A, so one of the intersecting points was A. The other one over here is D. So wherever that original circle crosses AB, those are the 2 points we want to use. From those 2 points then, we draw our next 2 circles. You would take your compass, set it at point A, open it to point D, and then draw a circle with the center A. That gave me this circle here. Then you go to point D, so set the compass at D, open it to A, and then you would draw that circle. Where those 2 circles intersect, one should be below the line, one above the line, give you the 2 points you want to connect. So in this case, I labeled them E and F, and they should pass through C and cross line AB at 90 degrees. And again, I'll create a second video taking you through step by step how to do this construction. But based on that construction, we now can say that line EF passes through point C, which we wanted, and it is perpendicular to line AB, meaning it crosses at 90-degree angle. So the majority of this lesson is going to be applying the idea of perpendicular bisectors and perpendicular lines, and then being able to do the construction of a regular perpendicular bisector and a construction of a line perpendicular to another line through a given point. So what you'll want to do is now, with this video done, you'll want to watch the video on doing those constructions.